All
right, theorem number 3. This is probably considered actually combinatorial Nullstellensatz. So I'll just write.
I thought you were going to say actual income. And then you kept going.
Wow. I shouldn't write this more than once.
Yeah.
Yeah, it's like Yasuo writing his name.
Noga Alon. And actually, the thing is, it came out in 1999. Okay,
Whoa.
so you think about it. Like it came out in this paper came out in 1999.
No.
The question.
Let's feel.
That's all right.
My time has come. But let me toilet paper.
Yeah, just there's also like sort of towel-looking like stuff. Yeah. So it came out in 1999. It made like the IMO meta in like 2007.
And since then has disappeared.
And then I guess people started to realize like trying to make it into a topic in like 2013 or something.
Did it work?
Well, I guess so. We caught on to it somehow. So the actual theorem goes something like this. So what do you have? You have an f, yeah? So the other conditions came from this theorem. It has n variable polynomial, yeah? The degree of f is the sum of ti's, yeah?
Yes.
Where ti has no meaning at the moment.
Reminds me of lemma 0.
Yeah. Oh wow, you cleaned that up quick. It's actually maybe we should encourage Will to spill because the table ended up cleaner than. So if x1, x2, t1, t2, yeah, xn, tn is a term. It's like has a non-zero coefficient in the expansion. Yeah. Maybe I'll abuse notation by saying that's an element of f.
Suspicious.
Yeah, suspicious. Okay. There needs to be some s's in here. Some s's. Oh yes. So you have SI, subset of F.
Epic Sunday.
Yeah.
Indeed.
And the SIs are bigger than
TIs.
TIs, yeah.
Seems very much like lemma 0.
Okay. Then the conclusion, written right in red, is that F of S1 Sn is non-zero for some
Only some
S1
SN.
and S1. It's non-zero.
Oh, wait, didn't we try to use this to prove the IMO question? IMO question 3, I think.
Yeah, so
yeah, this thing here. IMO question 6.
Oh.
The one we had on this side.
So, yeah, okay. We should have the previous statements on the other board so that we know what they are.
Yeah.
oh, well, if you're logged in, I guess.
Okay.
There's
Lemma 0.
Oh yeah, I guess you've only seen it for the first time.
What's lemma 0?
We spent all week memorizing them.
What's lemma 0?
Huh?
What's lemma 0?
Oh, it's like f is equal to 0 on a whole bunch of things, and it's therefore f is 0.
Yeah. And
Yeah.
then S2 is if it is if you define
That could be a memory test for you. Yeah.
If you define the G that way, and then you have the X as
greater than T1 for T1 equals degree.
Yeah, and that's now as
the degree of F.
Yeah. So
Then F equals 0.
And F.
Okay, so that's the lemma you just there.
Yeah, that's the lemma. Okay, now theorem 1.
Yeah, theorem 1 is
F is equal to GI.
F is the sum of HIGIs.
So if GI is that, and then F of S is equal to 0.
Yeah, and the HIs have degree.
So HI has the
degree of HI is less than or equal to the degree of FI.
Oh. Hey, you're not dead yet.
Minus.
Oh no, it's because I slept early.
Oh, you slept early and gamed in the morning, so fresh.
and cereal.
Yeah.
Fresh.
Basically
Oh, and the
what it was.
cereal.
There's basically just one, you just woke up basically. Had that breakfast.
We need hammocks.
Oh, we do.
They're just having some on the balcony.
And it's
Alright.
swings Yeti.
So the conclusion is that F is not 0. Is that crazy?
Almost, everything else looks like, if you're not paying attention, the conditions look exactly the same. And
Then the
something
conclusion is
like,
different. Yeah. Yeah, so basically, the way they prove it, right? So you assume it is 0, right? Proved by contradiction. And then you can get somewhere with the other lemmas and theorems, right? So assume that it is 0, yeah? Assume F equals 0 for on all of the S's, yeah?
Yeah. Then you have, then F is some HIGI, I guess, somehow.
Yeah.
Maybe.
Ah.
To realize.
Yeah.
Yeah.
Okay. Then F is equal to sum of HIGI, right?
Yes.
Does it just straight up work, or you have to do a bit of extra fiddling? on
Pretty
that?
sure it works if I remember correctly.
Like,
Oh, and then we look at the degrees, I think. I think what's
yeah,
the
you have to,
degrees?
like, you have to make sure
Yeah.
it's not weird.
So like, so what's it called? The sigma of Ti must be greater than degree of, I think it's something like sigma of Ti must be greater than degree of Hi. Gi, and I think that just doesn't work.
Yeah, so
It's something like this.
okay, so the key thing is that F has to have this monomial in that way, right? So if F has it, then this has it as well, right?
Yes.
So the xi term. Yeah.
Oh,
So that has to be in the right hand side and left hand side, right? And so if that monomial is going to come from some HIGI, right? Yeah. Okay. But the problem is if you look at GI, right? So that's actually equal to HI times a whole bunch of like XI minus S's, right? And the S's come from SI, right? So because the degree of F, yeah, the degree of H can be at most the degree of F minus the degree of G, right? That was one of the conditions.
yeah.
That means for you to get this term, so this term obviously has degree of F, right? The term that XITI term, right?
Exactly. Yeah, it has degree
F has the highest possible degree, yeah.
Yeah.
So to achieve that, H must have the highest possible degree, right?
Yeah.
Or H.
And G has to have the highest possible degree. Because the degree of HI, right, by the other lemma,
Degree of HI, yeah, less than.
is less than degree of F minus the degree of G, right?
Yeah.
So
Or
if you take the biggest degree thing in H, right, and the biggest degree thing in G, you just might make F.
Wait, why don't you take the smallest degree thing in G then? Oh, wait,
Do I have it the wrong way around?
okay, you take the big. Wait, how do you know they're the same? Are they necessarily the same height?
Yeah, these are the same height.
Picture comes at last. Level 14.
All right, make sure you tell it level 14. It's on your right.
Level 14 on your right. You just turn it off.
I know.
Is she in the
You press
Discord?
it once, but you press it twice. Oh.
Why have you done this?
Is she just locked outside? I wish we had the intuition to press again.
Yeah.
Or not. Just find it. Or she could just
Break
stay
in.
down. Wait, so
Yeah, so the degree of H, right, is at most the biggest it could possibly be is the degree of F minus degree of G, right?
Yeah.
So if you times the G with the H, it's at most a degree of F, right?
Yeah.
So for you to get a degree F term, right,
yep. Then
you need to times the biggest terms of G with the biggest term in H to even have a chance.
So she coded.
Yeah.
Yeah.
So you're basically taking the one like
You can't get in.
Usually, to make sure someone hears it, you wait for a reply. Yeah, this is communication 101. Yeah, hello, yep. Level 14. Okay, got it. Yeah.
Wow.
This is exactly the problem that maybe made her come at 3. No communication at all.
No, she's gonna be stuck down there until 4.
It's like, I'll get there before 2. And then it was like, and then 3. And then it's like, I had to call her.
Yeah.
You know what I mean? It's just simply message. It's like, oh, we're going to be an hour late. It's communication. Yeah, it's embarrassing. But it's more annoying when like
But they are asking.
when I have to ask, yeah. Okay, so basically to get so we're looking for the XI term, right?
Yeah. Yes.
And basically to get it, you need the biggest terms from H and G. Yeah?
Yeah.
Does that make sense?
Yep.
Okay, to even have a chance to get it. Okay. But the problem is, look at what the biggest term in G is.
Chemistry and SI.
XI.
It's XI, and it's got some power that's bigger than SI, right?
Yeah.
Bigger than
The
SI.
size,
Yeah.
the size of
Oh,
SI,
yeah.
yeah. But SI is bigger than TI, right?
SI is
Oh,
bigger than
so it's
TR.
bigger than TI.
Yeah.
Oh.
So the term that you actually get has to actually have more XIs in it than you need, right?
So you have an excess on one side.
Yeah.
Oh, so wait, it's okay. So like,
That makes sense.
yeah. So basically, it's like, okay, you need the maximum, you need the biggest one because otherwise you don't add them up.
To the
But
right
the
degree.
biggest one is too big. Well, so basically, it means that you're like sacrificing the degrees of other
Yeah.
terms when you play. It doesn't work.
Couldn't get in.
Yeah.
Did you like lock it? What happened? Tell her to ring again.
Maybe we should send someone down to get her. Send someone down to retrieve her.
Okay, and so if that's the case, then it actually has no term like that on the right hand side, yeah? Because all of the terms have too many XIs in them to be that one. Yeah? That's a contradiction.
Yes. Yeah. And so therefore you cannot do it.
Yeah.
Oh.
Ah.
Send someone down to get her.
Yeah.
I